Hello everyone, I hope you can hear me right now. So I'm just waiting for feedback on the group to make sure that my audio and video is working fine. So if everything is working fine, you should probably see building mobile game solvers on the screen and my name below that. I'm just waiting for some feedback in the group. If anyone tells me that everything is working fine, then I will go ahead with the talk. So I'm still. Okay. Brad wants me to tell him when I start. Okay. Brad, I started. Let me know if everything is good. Okay. So I'll just be talking something, so one of you guys can give me feedback that the audio and video is fine. Okay, so let me just draw something on the screen. I hope everything is fine. I don't know. If everything looks good, I'm going to start the talk. Okay, how do I erase this? I think I have to go to pointer options and erase all ink on slide. Okay. Okay. Brad sent a message in Chinese. I'll have to translate it. Okay. Began. Oh, great. So Brad told me that he can hear me clearly. So that's awesome. So I'll get started. Okay, I'll just use my pointer here. Okay. So hello everyone, this is my talk. I'm Surya and this talk is for the PaoPao Robot group, and I'm going to talk about how we can build mobile game solvers, and at the same time I will be looking at your feedback on the group, and depending on your feedback maybe I can tweak around my talk. So if something is not clear, feel free to put that up on the WeChat group, and accordingly I'll change my talk. And preferably if you directly send the message in English, that's easier because I don't have to translate it. Right. So let's go right ahead. I actually wanted to show you some demos before getting started on the kind of things that we can build. But right now, I don't think the videos would work well because this is a live session. So I'll share the slides later, and you can take a closer look at the kind of things we can do by using the hyperlinks on the slides. But right now I'm going to tell you, instead of showing the video, about what we are really trying to do here. So basically what we are trying to do here is to automate mobile games. So there are a number of interesting mobile games. For example, one of the mobile games that is very interesting is called Piano Tiles. And in that game, you have, so this is the mobile screen, excuse my bad drawing. And the screen is divided into tiles. So this is the demo of the game Piano Tiles. And you have tiles covered in a specific pattern. And these tiles keep going down. They just keep going down very, very fast. And as the tiles keep falling from the top, you have to click them at the right time. So I think a demonstration would have been better, but I'll try to explain as much as I can here. So this slide keeps going down, and you have to click it before it goes. So everything keeps sliding down, and you have to press the colored tile as fast as possible, so that the speed at which the tiles go down keeps increasing, and you have to do it as fast as possible to stay alive in the game or you're dead. And this is one of the game that can be automated using the techniques that we are going to cover in this video. And there are a number of other games, and I think this technique is especially effective for puzzle games. Um, so I think this is a good example. Many of you might know Sudoku, which is a puzzle where you have to fill numbers in a specific way. So it's like this, and you have to. Oops, I'm sorry. Okay. So you have to fill numbers in a specific pattern, and computers can do these well. So this is another application for this technique. You can automate games like Sudoku very easily. So let me see if there's some feedback in the group. Oh yeah, Brad says Piano Tiles is a famous game played for a long time. Yeah, yeah, that's true. Yeah, that is a very interesting game. So let me move on to the next slide. Okay. I started the organization Game Automators with a few of my friends, and the vision was to make learning fun. I would like to briefly tell you the story of how Game Automators came up. So after I graduated, I completed my undergraduate in India, and after I graduated, I just wanted to take some time and think about what I wanted to do next. And then I had specific ideas on which I could work, and one of the ideas was to automate games. And so I went back to my campus, formed a small team, and we started automating games. And we did automate a number of games. We automated about 40 games, and the codes for 20 of them are online, and you can find all of that in www.gameautomators. I hope my handwriting is not too bad. You can just go to this website and you'll find more details about that. Some of my friends said, well, if you are automating games and making high scores using a computer, you're killing all the fun. Is it really fun? For someone who would argue that way, I would say that it is really fun, and I would quote my experiences on how fun it was. So I started off in game automation by building a circuit that could solve the game Piano Tiles. So Brad posted the link of the website on the group. So thanks, Brad. So if anyone wants to check out the website, you can use that link. Okay, coming back. So we built a circuit to solve the game Piano Tiles, and the video is in the previous slides, and you can check it out later. So this video went viral. It got lots of views. I think right now it has about 300,000 views on YouTube. So it really went viral, and that is so much fun to see that so many people are looking at your work and appreciating your work was so much fun. So I think building mobile game solvers is really fun. And after I went back to my campus to build a team to solve more games, I mentored a number of people at my college, which is NIT Warangal. So people with no prior experience, people who had no idea what image processing was, who hadn't worked on any electronic circuits before, were able to solve games in a few days. So it was really exciting for them, and they started learning very quickly, and they started solving games. So I think this is a really good way to help people get started with concepts of electronics and image processing. My video of Arduino playing piano tiles going viral is evidence that people are really excited to learn this stuff. So after this video got so many views, number of viewers wanted me to post a video tutorial of the same, and we did that. After posting the tutorial video for the same, it went even further viral. I think right now it has like 600,000 views. So this is cool stuff that people are really interested in. Okay, enough of the background, and let's go into how we can solve games. So yeah, Brad in the group says there are 300,000 views on Surya's YouTube channels. Yeah, there are a lot of views on my channel, and you should check it out. And I will post the link of my YouTube channel later after this talk. So there are mainly 3 approaches that we can use to solve games. I mean, these are the approaches we have explored. I am sure that there might be other more efficient approaches, but in this video I'm going to cover the approaches that we thought were easy to implement and very effective. So one approach is using image processing, one approach is using electronics, and another approach is using image processing and electronics. And each of this approach has its own advantages and its own disadvantages, and I'm going to talk about them a little later. So let's jump right into the approach 1. So approach 1 is using image processing. So this is the block diagram of how things go. So this is how it works. You connect the phone to your laptop using a USB. So let's say that this is a USB connection, and it connects to your Android or iPhone. So most of what we have done was for iPhones, and it connects to your laptop. So the first thing we need to automate the game is to see what's on the screen. So we use a library called ADB tool, and this library can be used to do a number of things. So there is a command in this library that you can use to get the screenshot of what's on the screen onto your laptop. So that is really cool. It's like having eyes, right? Just like how a human sees the screen, you could use this library to transfer the image of what's on the screen of the phone onto your laptop. And I'm going to show you commands on how to do this a little later in the talk. And yeah, okay, I just see Brad saying it's exciting. Wow, that's nice. Okay, so the first step is to send this screenshot onto the laptop, and then you have to process the image using some kind of software. We used MATLAB for most of the games here, and then you have to simulate the touch. But you don't have to physically click the screen. Again, you have a function inside ADB tool. It's something like touch at the position x, y for a time of 100 milliseconds. So that's how easy it is. You can just use this command to touch at a specific location on your screen. So that is very interesting. So one of the main disadvantages of this approach we found was that ADB tool was too slow. So it took about 0.5 seconds to transfer the screenshot from the phone onto the laptop. I'm sure there are more efficient ways, but we haven't explored it that much. But if you guys can suggest more efficient ways, that would be great. But the problem here is it takes 0.5 second to transfer the screenshot, and it takes 0.5 second again to simulate the touch. So if you want to play games which are time sensitive, where you have to react in like 50 milliseconds, it's too hard to do this. But if you're playing puzzle games which have like 3 minutes or unlimited time, then it's far more easier, because this delay in time wouldn't matter that much in games where time is not that important. So let's go on to the next approach. Okay, so this is an example of the game that uses image processing to okay, this is the example of a game which can be solved using the approach that we just covered. So I'll explain a little bit about what this game is. So initially you see this little sprite, this little person. He needs to navigate from pillar to pillar. So that is our goal. So initially he's going to stand here, and when you tap on the screen, so when you press on the screen with your finger, when you press on the screen, a stick keeps coming up, and the stick keeps increasing in size. So if you press for 10 milliseconds, say 100 milliseconds, your uh, your your stick is going to be this high if it's 10 milliseconds. If you press it, if it's 100 milliseconds, if you press the screen for 200 milliseconds, it's going to be 2 times as high, right? So the goal of this game is to press the screen for the correct amount of time, such that once the rod gets constructed, once it falls onto the next thing, onto the next pillar, it has to fall on the next pillar. So if you press this for too long, you're going to get a very big, very big rod, and it's going to fall somewhere here, and you're going to die. You're going to die. And if you press it for too less of a time, then your rod is going to only come till here, and you're going to die. So you have to press for the right amount of time, and that is very important. So this is one game that can be solved, and we will look into the code of this specific game at the end of this session. Another approach is using electronics. So this is the game piano tiles that I was talking about. So the tiles keep falling down from the top of the screen, and you have to press the tiles as fast as possible. So what we do is use sensors. You use light sensors here, and because there are 4 series of tiles that are coming down, you have 4 discrete sensors here. You tape these sensors onto the screen to see if a black tile is coming or a white tile is coming. So as soon as you sense a black tile somewhere, you have to press the screen, and you again simulate the touch using a relay and a coin. And I'm not going to go into the specifics of the electronics right now, but I'm going to give you material that you can read, or you can just go to the website and you will certainly find more details on how the touch works and which specific sensors we used. But the basic idea here is that you keep sensing, and inside, so Arduino is a microcontroller that we used for this specific application. So the code is going to be very simple. So if you detect black, then click. And this needs to happen for all the 4 sensors that we have. So we just have to do this in a loop, and that is going to work great. So this is how we solve the game Piano Tiles, which is this game where tiles keep falling from the top. And this was really interesting to solve, and this could break many world records, as in the highest scores that people made. This circuit could beat the highest scores in many modes. And it was very interesting because this brought up a community online of game solvers. I could see other people who built their own bots to compete with this one and tried to make higher scores than mine. So that was exciting again. And then the third approach is to use both electronics and image processing. So I just have a comment on WeChat. So Brad is asking me, can electronics method be real time enough? I saw your video before, it's so fast. Yes, I mean, the electronics works insanely fast. I don't know, I would guess that it's around 10 milliseconds. I might be wrong here, but that is just a rough estimate of how fast electronics can react. And we as humans take a lot of time to react, right? We have to move our finger up and down, and that takes a lot of time. So in this specific game, this circuit really outperforms humans. It's just too fast. So let me move on. So approach 3, using both image processing and electronics. So we are using this approach to get rid of the delay problem that we had in this step. So we had in approach 1, while using image processing, we had a huge delay, a 0.5 second delay. So this delay is largely because this library saves the screenshot in, it encodes the screenshot in .png format and saves it on the phone's hard drive. And then the file is sent to the laptop again through the USB. So I think that's probably why it takes so long. And this is really not an efficient method where you have to do things fast. So to get over that problem, we can use a webcam. So when you use a webcam, you wouldn't have the 0.5 second delay because it can stream at 30 frames per second onto your laptop. So this problem of delay during sending the screenshot from the phone to the laptop is solved. So because data can go in very fast. And then another problem you have was during the touch simulation, where you had a delay while using the ADB tool library. So instead of that, if you use the Arduino, the advantage is that it can react very fast in milliseconds. So this could be really helpful to solve games where you have to be as quick as possible. And one thing to observe here is the webcam needs to be placed in a way that it covers the whole screen, or maybe a little more. It has to see everything on the phone. And again, you have to use some kind of pre-processing algorithm because the data that goes into the webcam depends on the external lighting conditions and stuff. So the image processing gets slightly complicated, but if you want speed, I think you have to do this. And I think there are approaches where you can feed data faster into the laptop, but I was not able to find them. It will be great if you can suggest any of those methods. So this is the example of a game that you would want to solve using image processing and electronics. Now, I hope you know the game Flappy Bird. So this was a game that went viral, and I'm going to explain. So you have to keep tapping on the screen. So whenever you tap, that's a hand, I'm sorry for my bad drawing. So whenever you tap on the screen, the bird goes a little up. And if you're not doing anything, the bird goes down. So you have to keep tapping at a specific frequency, at a specific tap rate, maybe 10 taps per second, to make sure that it is going in a straight line. I think 10 taps per second is too fast. It would be around 3 taps per second maybe, to make sure that it goes in a straight line. And then you have obstacles that are coming up, and you have to tap the screen in the right way so that it can navigate without hitting the pillars. And so in this game, you have to react very fast. I think you have to tap every 200 milliseconds. That is a very rough guess. So you have to be very quick. And if you use ADB tool for transmitting and the screenshot alone, it takes 0.5 seconds. So the first approach doesn't work here, and this could be a good approach to use instead. Great. So I'm going to show you a demo of the first approach where you use image processing to solve the game. So let's go into my MATLAB window. Okay. Okay, I have some other project here. I'm just going to clear everything. Okay, so this is the code okay, I'll just run the code and explain what's happening after that. So let me just run this. So when I run this, I hope you can see this image, or I'll zoom a bit. So this is the game. So this is the game's stick hero that I was talking about. So when this little, I guess this guy is the stick hero. When this guy is here, you have to type the right amount of time so that the stick goes just as long to fall onto the next pillar. So this is how the screen of your phone is going to be like. Okay, so I think I have a message in Chinese, so let me try to translate it. Okay, anyways, so getting back, now, so this was the input to the image. It was a screenshot of my phone, and if you see the output, okay, looks like I did not print the output here. Let me do that now. So display, I'm just going to display the output. So click the screen for fval. Okay, so I'm just running the code again with displaying the output, and I'll just turn the warnings off. It's just because I'm using a big image and that doesn't fit on the screen. So warning off. Oops. Okay, so I hope this should work. Okay, let's run the code again. So now this is the input and this is the output. Click the screen for 469 milliseconds. So that's how precise your answer can be. And this data can be used to tap the screen for a specified amount of time, and then the stick would increase to the height that it should when the screen is tapped for 649 seconds, which might be till here, and then it's going to fall right onto the next pillar. So yeah, that is how this game works. Now I'll just go a little bit into the code and then explain how things are going here. So I hope the font size is big enough for you to see. Okay, so let me go ahead. So the first step that we're doing here is reading and displaying the image. So to read from the phone, you could actually use these two lines. So I just commented out these two lines because right now my Android device is not connected and I'm just using a default image that has already been saved on my laptop. So let me tell you what each of this step does. So this command is from the ADB tool library, and what it does is, what it does is it captures the screen and then saves it on to the SD card with this name. And then this command is going to pull that image and save it onto your working directory, and you will be able to see the image here. So once you run these two commands after connecting your phone, you should be able to see the image. Let me show you the image. So once you run those two commands, this image should be on your laptop screen, on your laptop hard drive. So right now I'm not doing that part, so I'll just comment these out. And once you have it on your hard drive, you can use this command. Okay, I have a comment, I'm just reading it. You can pull images directly from your Android phone using screen cap. Yeah, so yes, Brad, that is a good question. So Brad is asking me if this command is sufficient to pull the image directly from your Android phone. So it's not just this command, but a combination of this and this. So the first command only saves the image on your phone's hard drive, and the second command pulls the image from your phone's hard drive onto the laptop. So I hope that doubt is cleared. So I'm just reading the image into MATLAB here and displaying it. So I'm not going into much details here because I think many of you do know MATLAB. So let me run this section. I'm going to run these section by section and show you the output. Okay, so when I run this section, you can see that the image is red and we are just displaying it. Now let us go on to the next section. So, okay, now let me display the image again. So now how do we process this image? How do we know the distance between this pillar and this pillar? Now if we want to know the distance between this pillar and this pillar, we can just slide along and see where we find black pixels along a horizontal line. So let me just try to draw here. So when you have a screen and when you have pillar 1 and when you have pillar 2, a good way to find the distance is to just look along this line, along the horizontal line, and see where you have black pixels. So you're going to have black pixels only here and here. So depending on that, we can find this distance, and that is the logic we are going to apply next. So let me go back onto my MATLAB screen. Okay, so now as you can see, I'm cropping this image. Let me run this section. So I just did run that section, and I'm going to show you the cropped image now. Okay, so this is the cropped image. So I think this should make sense. Now all these pixels here are 0, 0, 0, 0, and all these pixels are 0, 0, 0, 0. So only this part of the whole image can give us information to determine the distance between the two pillars. So once you get the image, I'm just splitting it into the 3 layers, R, G, and B. And in the next section, so let me just run the section first. I am thresholding and finding only the black pixels in that specific image. So I'll just show that to you. So I am show of black. You can see that only the pillars are in white color now and everything else is black. So now we are able to discriminate between the black pillars and the background by using this line of code. And then we are using region props, and I hope you know this function, but I'll just tell you what the function does in brief. So this function returns the statistics of all the connected images of your input. So for example, now if this is your input and you apply region props on this image, it returns all the statistics of the first connected image, which is all these white pixels, and it also returns the statistics of the second connected image, which is all these pixels. So these are all this is number 1 and this is number 2. So this is going to be returned and saved in stats. So next, so let me just show stats for you. Okay, so you have 2 fields in stats, and the first field corresponds to the first connected white pixel set, and the second field corresponds to the second white pixel set. And you can see that we have the bounding box values of each of these pixels. So you know where this is starting and where this is ending. You also know where this is starting and where this is ending. And we can use this information to find the distance between both the pillars, and that is what we do in the next step. So we're using that specific properties to find the location of, I think y1 depicts the end of the first pillar, and so which is probably this, and y2 depicts the start of the next pillar, which is this. So we're going to use these two and subtract them to get the distance between them, which happens in the next section of this code. So you're going to subtract them to get the specific value of the distance. So let me run that. So yeah, now once you get the distance, we are going to use a linear function to determine how the fval changes. So fval is the amount of time you have to press the screen for. So let's say that, so let's see what the value of distance is. So now the distance is 479 pixels. So now we cannot directly press the screen for 479 milliseconds, because that might not be the logic that has been used in creating the game. So you have to use a kind of y equal to mx plus c function. So let me just write that here. And this is your distance, which in this case is 479 pixels. And we have to just tweak around with the values of m and c until everything works fine. So right now we could, so for basic games like this, you can just tweak around with the values until you get you find the right ones. And if you have more advanced games, then you can use machine learning to train your data on a linear model and find the values of m and c. And that would be a more professional and logical way of doing this. But for now, let's just stick to the trial and error. So by trial and error, I was able to find that the value of m is 0 and the value of c is -10. And this seemed to work. And based on that, we are just going to click the screen for 469 milliseconds. And after this, we have to simulate the touch on the screen. And I'm not doing this right now. This has been commented out because I did not connect my phone. And if I connect my phone and if I leave these uncommented, the game is really going to be played on my phone. So let me just uncomment this and tell you what this does. So this is the function. Okay, I have a question. I'll respond to that first. So Brad is asking me, did you calculate the values of m and c manually? So the values of m and c here, I didn't calculate them manually. I just tried. I started off with m2, c 0.5. It didn't work, and I just kept tweaking around until I found the right values. So I was just changing numbers until everything worked. So yeah, I guess I did that manually instead of using machine learning. And so there are more advanced games where machine learning makes more sense, and we did use it for some of the games. And maybe if we have another talk, I could cover those games later, at a later point of time. And so this is the function that is going to simulate touch on your screen. So let me just show you what this is. Oops, okay. I'm just going to show you the command. So this is the command that your system is going to run. Okay, once you initialize the command, you should use the same function which was used above, system of cmd. So once you use this, the touch is going to be simulated. And this is the command. So let me tell you what all these parameters in the command are. So this is actually not for a tap, but for a swipe. So you swipe from x1, y1 to x2, y2 in this much time. But right now, because we only need a tap, we're going to make everything equal, and we're going to assign it any value because it doesn't really matter in the game where exactly you tap on the screen. So we're just taking some values, and these values don't matter. And based on these values, these are just values that are on the screen. So you're just tapping the screen at, say, so if we have the image, where is the image? So this is the image. I think 10,10 would be somewhere around here, or somewhere along the top, but that doesn't matter in the game. You can tap anywhere on the screen. So these values really don't matter, and what really matters is this. So you just have to run this whole code in a loop. to keep the game playing. And you might need a pause in between, a pause for 3 seconds, so that the simulation of the man going from here to here is completed. So you just have to run this code in a loop to get things done. So yeah, I think I would like to end the talk here. I think it has approximately been, I don't know, half an hour or 40 minutes. Yeah, or 20 minutes. I think it's been 40 minutes. Yeah. So yeah, I would like to end the talk here. I'll just wait for a while and see if you have any other questions, or else we can end the talk here. And if you want to learn more, you can just go to gameautomators.com and you can either read the book or download the book. And we have covered specific concepts there, so I'm just going to show you the book here. So when you say read the book, you would get an online version, and when you say download the book, you're going to get a PDF version. So these are specific specific sections that cover, and you have various games covered here. Okay, so Brad is asking me if I could show some demos. So yeah, I will try to show some demos, but I'm not really sure if the live session can get them well. But okay, let me try. Okay, where is my... Okay, I'm going to show... Okay. Let me show you some demos. Okay, I'll show you the demo of Unblock Me. Okay, let's look at a game that we already understand. So yeah, let's look at the demo of the game Find the Difference. I'm not sure if you will be able to hear the sound well, but I don't think the sound matters. So yeah, Find the Difference is a game in which you have to look at the difference. You have to find the difference between these two images. So for example, maybe you have a shadow here and you don't have a shadow here. You have to click that. And suppose you say it's in red here and green here, you have to click that. So this is generally a little hard for humans because we tend to just recognize objects directly. We don't look at it in a pixel by pixel fashion. But because MATLAB looks at it by a pixel by pixel fashion, you can just crop the first image, save it in a matrix, crop the second image, save it in a matrix, and just subtract them, and you would see all the differences. And depending on wherever you see the differences, you can simulate a touch at that specific point. So this is the computer playing the game. So if you can see the circles coming up. But then you can see that this is a little slow. It is slow because MATLAB, because ADB tool is a little slow. You take about 1 second to detect all these. So yeah, that is how we can solve this game, and there are a number of other games. You can check the website. I think we have about 7 games on the website. Is it 7? We have about 7-8 games on the website, and if you look into the GitHub page for this for Game Automators, you will be able to find about 20 games there. And yeah, and we also have a section on setting up ADB tool, which could sometimes be a little effort. So yeah, you can just browse through all the sections, and if you're interested, you can just try to automate some of these games. So yeah, I think that's it for now. I will just end the video here. It's been a great talk. Okay, bye bye everyone.